In microwave communication, the multipath fading caused by the multipath effect impacts communication quality. The multipath effect is common in areas where transmission paths encounter serious water surface reflection, such as coastal or lake areas. The multipath fading is especially apparent for long-distance microwave transmission. The multipath effect occurs when microwave signals are transmitted on different paths and direct waves overlap with waves reflected after traversing obstacles. This process produces interference and distorts the original signals. The space diversity (SD) combination technologies can effectively minimize the impact of the multipath effect. With the SD combination technologies, two spatially separated antennas receive the same RF signals. As the main antenna and diversity antenna are spatially separated, correlation between the two channels of IF signals is low. That is, the multipath fading does not usually occur on the two channels of signals at the same time. So the positions of notches are different for the two channels of signals. SD combination combines two channels of signals from two spatially separated antennas, as the fading of the two channels of signals is not totally the same. The combined signals can greatly reduce the impact of the multipath fading. On long-haul LH devices, received signals are combined by the IF combiner of the RFU SD, so SD combination is also called SD-IF combination. In addition, the branching unit, BU, must be of the SD type. After the transit end sends RF signals, the RFU SD at the receive end uses two RF receivers to receive RF signals from the main and diversity antennas, respectively. After the two channels of RF signals are converted into IF signals, the IF combiner combines the signals into one channel of IF signals.